warm chocolate bread pudding. What would you want today except for a warm dessert? Clearly. And the afternoon will go in much the same way as the morning. We have 4 more presentations. The presenters will speak for between 15 and 20 minutes. We'll have some time for questions. And then we will wrap up. Again, thank everyone. Thank you all for being here. And the students for doing great work. And the first presentation of this afternoon, and we gave her this slot because we knew that she would be able to keep everyone awake immediately after lunch, is Raleigh McElvery, and her thesis is Trial and Error, Medical Marijuana, the Absence of Evidence and the Allure of Anecdote. All right, Raleigh.
Medical marijuana is an effective therapeutic. So we've had thousands of anecdotal reports to suggest that it would be an effective means to treat a bunch of different conditions. So like glaucoma, and epilepsy, and AIDS wasting syndrome, neuropathic pain, nausea associated with chemotherapy, and so very many more. But the fact that it's still illegal federally makes it difficult for researchers to, get study funding and study approval to examine marijuana, otherwise known as cannabis. So I've looked at this issue from a variety of different perspectives for my thesis. Caregivers and patients, clinical researchers, basic researchers looking at animal models, pharmaceutical companies, as well as dispensary owners and growers. But I wanted to start off by introducing you to a pair of characters that are woven in and out of the written narrative of my thesis. So I'm going to start off by reading an excerpt from the beginning. Christy Shake gets her marijuana from a local dispensary. Since the blossoms contain most of the plant's medicine, she crushes them, soaks them in sugarcane alcohol, strains them twice, freezes them, strains them yet again, and evaporates the alcohol. Once the remaining resin has become thick and dark like molasses, but far more bitter, she dissolves it in coconut oil and feeds it to her 13-year-old son, Calvin. Calvin suffers from epilepsy, as well as a set of developmental disorders impairing his ability to walk, talk, and speak. The neurologist predicted he might never even crawl, but Christy refused to accept the prognosis and spent a year physically moving Calvin's hands and knees along the floor. As a teenager, he is now relatively mobile, but his balance and coordination are poor, and he depends on Christy's assistance to get from place to place. 4 years ago, Christy began researching medical cannabis online. After consulting an experienced herbalist and fellow parents, she began treating Calvin daily with a homemade cannabis oil to assuage his epilepsy, which was resulting in about 4 daytime grand mal seizures each month. She has perfected her recipe over time, culling bits and pieces of information from various parents on the internet. After all this, Calvin's condition seems to be improving. He's only had 3 daytime grand mal seizures since about 6 months after we started using the cannabis oil, Christy said. This is not another story about the miracles of medical marijuana. Yes, Calvin's seizures have eased remarkably since he started the regimen. But even in light of thousands of other cases emphasizing the plant's many therapeutic benefits, it's not enough. Lacking rigorous scientific studies, these anecdotes are essentially all we have. So just to kind of give you the current lowdown on the situation, at the moment, 29 states have legalized marijuana for medical use, and 8 permit recreational or adult use. And however, of course, marijuana is still illegal federally, and it has been since the 1937 Marijuana Tax Act. And there were a lot of factors throughout the years that played into its stigma as a really dangerous drug. But what really solidified the government's anti-marijuana stance was the Controlled Substances Act of 1970. And that's basically just a way of dividing up drugs by levels of badness. So these levels are called schedules, and Schedule 5 are the least bad drugs. So drugs like Robitussin fall into this category, meaning that they have a low potential for abuse and currently have an accepted medical use. Whereas drugs like marijuana that are Schedule 1, as is heroin and ecstasy, these are thought to have a high potential for abuse and currently have no accepted medical use, which in the case of marijuana, quite frankly, no, it's just not true. But because marijuana is Schedule 1, that makes it difficult again for researchers to get study funding and study approval. So the next person in this cast of characters that we have that I wanted to introduce you to is Dr. Donald Abrams. And he is well known throughout the marijuana research community as kind of the poster child for having to overcome federal shenanigans in order to conduct his medical marijuana research. And so he was the assistant director of the HIV/AIDS program at San Francisco General Hospital during the height of the AIDS epidemic. And so he was able to witness firsthand marijuana's appetite-stimulating effects, as we all know. It has, just think of the munchies. And he thought this might be an effective way to combat wasting syndrome in people with AIDS, so involuntary weight loss, basically. And so what he decided to do in 1993 was convert theory to fact. And so he began designing a study to this extent, but he had to go through years and years of protocol resubmissions to various federal agencies in order to get approval, funding, and also to get the marijuana for study to give to his participants. So he didn't actually start enrolling participants until 1993, and his final paper wasn't published until 2003. So that's a full 10 years between, I guess, inception and completion, which is an abnormally long time for a study to have to go on. So when I talked to him back in January, he said that basically the approval process has not changed at all since the 90s. It's still this difficult. So I guess there were two main themes that would come up when I was talking to different medical marijuana researchers, two main obstacles that really made it difficult for them to conduct their work. And the first is NIDA, the National Institute for Drug Abuse. And so as is the case in most scientific disciplines, the majority of the research funding comes from the government. And so if you are a researcher and you want to conduct marijuana research, you have to go through NIDA. But as the name suggests, Institute for Drug Abuse, they're more likely to fund studies that have to do with drug abuse as opposed to therapeutic effect. And they are also the only agency that can supply marijuana for scientific study. And that's a big problem. We have this monopoly on the supply that we'll get to a little bit later. But the second obstacle is the DEA, the Drug Enforcement Administration. And what they do is they approve and distribute Schedule 1 licenses to study marijuana. And so they basically just ensure that the drug is being used properly in the lab and only for lab purposes and that kind of thing. But they have a bunch of persnickety rules that have really only gotten worse as the pro-marijuana movement has begun to unfold state by state. And so just to illustrate this point for you, I guess, I spoke with Dr. Aaron Lichtman, and he is from Virginia Commonwealth University. And so in order to get his DEA license to study cannabis in mice, he had to keep it locked in a 500-pound safe bolted to the floor of his office. And he chose his office as the location because he was the only one with access. He figured it's a pretty secure place to keep your marijuana. But in order to actually study it, he had to bring it over to the lab, which is in an entirely different building. And he had to go through an enclosed walkway, a divider. So the drug never saw the light of day, but because he was using it, or keeping it and using it at two different addresses, the DEA didn't like that and said you have to have a DEA license for every address that the marijuana is at. So some of his fellow researchers have 3 or 4 different DEA licenses. It's a little crazy. So that's just one of many examples. But I guess I told you I would get back to this idea of NIDA holding a monopoly on DEA licensed marijuana. And that's important because DEA licensed marijuana is the only marijuana that is permitted for FDA approved research. And I apologize, I know that this slide is a little cluttered and scary, but so is the situation, so maybe it's fair. But NIDA can only get or distributes their DEA licensed marijuana from one institute, and that is the University of Mississippi. And so talking to a bunch of different researchers for my thesis, the general consensus seemed to be, and to quote one researcher, the University of Mississippi, their product is basically crap because it doesn't reflect at all what people are using on the street or what you would get from your local dispensary. And the real kicker is that FDA requires that all phase 3 clinical trials be conducted with the same drug that will later be marketed, which makes sense, that's totally fair. But University of Mississippi product is only authorized for academic purposes. So not only are researchers only allowed to study something that doesn't really reflect what people are using in the real world, but they can never develop this into a drug that will be legally used by people in the real world. So yet another kind of catch-22 situation. But I guess it's not all bad news. So even though the DEA did back in August deny 2 more petitions to reschedule marijuana, they did announce their intention to license additional marijuana growers besides University of Mississippi. So that means that in the future, near or far, still unclear, you might be able to get a product for study besides what is offered at the University of Mississippi. So that has potential, but we shall see. So at this point in the presentation, I really just wanted to emphasize how little we know about cannabis thus far, and that's because it's a really complicated plant. It has over 500 naturally occurring chemicals, at least that we know of, and just over 100 of those are known as cannabinoids. And so not every strain of marijuana contains every single cannabinoid, and in fact, most strains historically have been bred to primarily include one cannabinoid, which is THC. And that's because that's the cannabinoid that is, causes the high that you get when you smoke or take marijuana. But it also has therapeutic properties. And so another cannabinoid, CBD, that has been more recently gaining traction because it has the same therapeutic effects as THC, but without the high. Not completely non-psychoactive because it does have anti-anxiety effects, but again, no high, so that's good. But to make the situation really even more complicated, the ideal combination of these chemicals for any given strain might vary depending on the person in question, obviously because we're all different, and also the ailment in question. So that means that one strain might be really effective at treating nausea associated with chemotherapy, but another strain might be better suited to address HIV/AIDS, wasting syndrome. So these are things that we are all still figuring out. So this is Ethan Russo, and he is important, a key player in my thesis because he was very much involved with GW Pharmaceuticals, which is a UK-based pharmaceutical company that works on developing cannabis-based drugs. And so most of these drugs include some amount of THC, but they basically all contain some degree of CBD, and in some cases they are just CBD. And that is the case with the drug that GW is currently working on, Epidiolex, which is an anti-epileptic, and it is just purified CBD extract. And so when I spoke to Christy, Calvin's mom, about this, she was really excited because before she started making her own homemade cannabis oil, she had tried 9 different anti-epileptics for Calvin, and up to 4 of them simultaneously. And so being on so many high doses of so many different medications, that gave Calvin a lot of tantrums, hyperactivity, chronic constipation. So when Christy heard of Epidiolex and brought it up to Calvin's neurologist, he actually had never even heard of it. And so Christy told me that this is just one in many cases where parents know more than the doctors do, especially about up and coming fringe treatments. And so I guess that's probably because this CBD-centric approach stands in stark contrast to what has been done more traditionally. So the U.S. has only approved 2 cannabis-based drugs to date, Marinol and Sesament, which are Schedule 3 and 2 respectively. And these drugs are basically just synthetic, so man-made THC, so no CBD whatsoever. But GW is not the only entity really interested in developing CBD-based drugs. The federal government, the U.S. Department of Health and Human Services, has actually held a patent on a class of CBD-like cannabinoids, including CBD, since 2003. And NIH has actually granted an exclusive license to Canalife Sciences Incorporated, which is an American pharmaceutical company, to develop this into treatment to look at 2 different conditions that result in loss of brain function. And so on the one hand, you have the federal government saying, oh, marijuana is a scary bad drug, it's Schedule 1, should stay there, we don't really need to study it. And on the other hand, they're also acknowledging that yes, there are components of this drug that could really be an effective therapeutic for a bunch of different conditions. And so, as Ethan Russo pointed out, and I'm inclined to agree with him, that this is just an irreconcilable situation. So I guess the last thing that I'll say about CBD is that there's currently a bill under review by Congress to possibly reschedule just that one chemical in cannabis. And again, that's another thing that's in its basic stages, so only time will tell, I guess, where that will go. So the final perspective that I wanted to share with you is the perspective of the dispensary grower. And so this is Fred Green, also Bowdoin alum. He spent 35 years as a commercial flower grower and has just now become a marijuana dispensary grower, actually for 3 different dispensaries that have either been built or are currently in the process of being built here in Massachusetts. And so he said, according to his perspective as a commercial flower grower, the marijuana industry is practically prehistoric. And one, obviously that's because it's still very young, people are still getting their footing. But 2, also because it's still legal federally, there are different requirements state by state as to how dispensaries need to be applied for, built, and run. And also at the moment, it's illegal to transport seeds across state lines because that constitutes drug trafficking. So that makes it difficult for growers like Green who get their seeds from Colorado or Canada. And basically, Green told me that the Boston Department of Public Health just kind of turns the other way and says, do what you need to do. We know this is kind of a screwed up situation. So yeah, another reason that the industry is basically prehistoric is that most of the current dispensary growers are what Green calls closet growers, who are now just emerging from their illicit closet practices. Meaning that, yeah, they're really great at growing 5 to 10 plants in their basement somewhere, but when it comes to growing on the order of 5 to 10,000 plants for a dispensary, it's definitely a different beast, and there's a huge learning curve there. And it doesn't make it any easier that there are currently no guidelines in place as to how to grow marijuana for a dispensary. And Fred Green has talked to a bunch of his peers about perhaps producing these guidelines, but so far everyone has shied away from it because of the stigma that is still associated with the plant. So at the moment, we're still in need of some serious standardization because you can go to a dispensary on one end of town, try the product there, and go to a different dispensary not so far away, and the products will be completely different because growing conditions affect the different ratio of cannabinoids that are in a given plant or a given strain. And as I mentioned before, that's really important to kind of nail down because different people have different reactions to different ratios of cannabinoids, and again, they are more effective or not effective at treating different conditions. So again, more work to be done there. So I guess the big question that's remaining still is what will the new administration mean for the future of cannabis and cannabis research? And this is something that I asked literally every single one of my interviewees, and they told me basically the same thing, which is that we have no idea. But they did agree that until, despite the cracks that are growing in NIDA's monopoly, until marijuana is rescheduled and no longer considered a Schedule I substance, things aren't really going to change all that much. So until we get to that point, really all we have are anecdotal cases like that of Christine Calvin. And I encourage you to check out Christy's personal blog, which she has been writing in since October of 2010, almost every day, to chronicle Calvin's journey. So yeah, just Google Calvin's story and it should come right up. And I wanted to, end with a quote that is also the end of my written thesis from Christy. And so this fall she told me, technically I could get in trouble. I'm all over the internet using cannabis. But I hope I can give other parents confidence because there's a fear factor involved when you're dealing with a substance that's not legal and hasn't really been tested like it should be. In the government, I would assume that they say because it's a dangerous drug that has a high potential for abuse and no currently accepted medical use. But all of the researchers that I spoke with and everybody else, all the different perspectives that I just went over, they're basically saying that it's a lot of politics. The politics are definitely ahead of the science in this particular issue. Looking at the history, which I didn't go into in this presentation, but I do in my thesis, there are a lot of different factors. Some like racial biases and that kind of thing. It's a very complicated history. So there is no, I guess, one answer that I can give you. I apologize.
Have we had other drugs moved from Schedule 1 to other schedules before?
That's a good question. I'm not sure. I know one researcher that I spoke with, he's the head of the Multidisciplinary Association for Psychedelic Studies, and he spent years and years trying to get ecstasy to be no longer considered a Schedule 1 substance because it can be treated or used to treat a bunch of different conditions like PTSD, that kind of thing. And he has not had any success thus far. So that's why he moved on to marijuana. But yeah, that's my knowledge. Yeah.
So we talked about how research is really impeded by the regulations and the sources, right? Now that only applies to the United States. Is there a body of literature internationally that has addressed some of these concerns with how cannabinoids affects medical use?
I think people are still, the research is definitely still behind on that front. I know some countries are definitely more accepting of marijuana than the U.S. is. I'm forgetting exactly what the, I guess more progressive countries are. But yeah, people are still, there's definitely arguments over how many species there are of marijuana. Some people, mostly accepted 2, but some people are saying, no, there are more. And there are just now other cannabinoids that we're discovering, like terpenes and stuff like that, that could, I guess, play into marijuana's effects in different ways. So to answer your question, I don't think so, not to my knowledge, even though I'm mostly focused on the U.S.
And another thing, what do you think that researchers can do to sort of help make change in the States?
That's a good question. I would say, well, continue doing their research. Obviously, don't back down in the face of having to overcome all of these different convoluted federal laws. And yeah, I guess just keep pushing these bills to reschedule CBD. There is actually another bill, I think it's still currently under review, to make the process less complicated to conduct medical marijuana research. So, yeah.
Did any of your sources, or did you develop a position at all on the potential tension between the current neurologic and functional neurologic imaging studies that are going on with cannabinoids, which really do appear to show some pretty significant neurologic changes, probably underlying therapeutic effect as well as toxicity, and the concept of liberalizing it from a class 1 agent?
Yeah, so you're talking about more of like the health ramifications if it does become more common.
Yeah, I mean, the real intent of class 1 is health protections issue, right? And the current neuroimaging studies suggest that there are really significant effects that were not anticipated on a number of neurologic structures of high concentration cannabinoids.
Yeah, definitely. So I talked to a bunch of different researchers because I was also, curious if this does become widespread, is that, bad for your brain? And general consensus seemed to be that really the main danger of marijuana is like a lot of THC, high doses of THC, so that definitely has like toxic effects. There are definitely like shorter term opposite effects of marijuana, that, like impairment with memory, impairment of motor skills. Those all tend to generally wear off. The data in regards to like whether or not it causes depression or schizophrenia, that's still very much like it can kind of go either way. I guess the main thing that marijuana has going for it, in terms or like compared to something like opioids, is that no one has ever overdosed on just marijuana alone because there are no cannabinoid receptors in the brainstem, which is obviously responsible for respiratory function. But all the researchers that I spoke with definitely said this is not something that a developing brain should use. Adolescents, just like alcohol, that can have some really, really bad ramifications. Yeah?
In terms of having a lot more standardized chemical composition for the drug to come with, is that something that you can control if you're able to control the soil and the strain that you're using? Or is there an X factor where it would be easier to do synthetically regardless?
Yeah, I think, just having 5 different seeds, even if you grow them in the same soil, will beget 5 different plants just because that's how Mother Nature works. So it seems like the way that things would need to go would be like tissue culturing. So basically growing cells in test tubes because that's what they do for flower sales at the moment. So there's only, I guess, one marijuana company, dispensary that is using tissue culturing to kind of standardize their product, and that is in British Columbia. It's like THC Biomed or something like that. So talking to Fred Green, he thinks that that's definitely the way things are going. He said he's actually been doing some marijuana tissue culturing in his kitchen. He said it's not that hard. So, take a word for it, but yeah.
how those are done, how they do them.
So you're asking specifically about studies from...
Johns Hopkins.
Oh yeah, so I haven't really read any of those studies specifically. I think you just mentioned PTSD. I did talk to, as I mentioned before, the head of MAPS, and they have just started enrolling participants in their PTSD marijuana veteran study, and it has taken them, I think, 7 years to get federal approval to do that. So they were super excited about that. I don't know if that answers your question.
Yeah. Is it going forward?
Yes, yeah. So they started enrolling participants in January 2017, and I'm forgetting their exact timeline, but they'll be gathering data for a while, and then I think that's going to be probably a couple years before a paper comes out of that. But that was a highly anticipated study, and I guess one of the co-principal investigators was fired from her current job at Arizona State University because of the stigma. It was a whole thing. So, yes.
Speaking of PTSD, and overcoming these political issues that you talked about, do you think that, politicians are always up on, we need to support the troops and all this stuff with the troops, and we need to reform the VA and all this stuff, like patriotism. And do you think if we couch marijuana research, this kind of research, in terms of PTSD and in terms of the benefit it can have for veterans who suffer from anxiety, depression, PTSD, that could help further along the politics?
Yeah, I don't know if I can personally answer that question, but this is definitely a good idea. I think that's definitely the way that things are going, with MDMA and that kind of treatment. At the moment, I don't know any specific numbers on how many people go to a medical marijuana dispensary in order to help treat their PTSD. At the moment, I guess the biggest use for medical marijuana is treating neuropathic pain, or not treating, but managing as well. So that's definitely the larger portion of the industry, but that's a good idea. Yes.
I've been hearing a lot about certain areas, certain states using medical marijuana to treat the opioid crisis. Mm-hmm. And I recently read a story about the state of Maine trying that. Mm-hmm. So do you think that theory has any promise in your opinion?
So treating the opioid, you mean trying to transition people off of opioids where you can overdose versus marijuana where you can't overdose?
Yeah.
Yeah, I mean, talking to all the researchers, they were definitely very adamant about the fact that marijuana is definitely a better treatment for pain than opioids. And I guess looking at the history, people have primarily been more interested in studying opioids because they're a lot easier to dose and we know a lot more about how they act on the body, whereas marijuana is still kind of, we don't know. So opioids have definitely been the easier route, but I definitely agree that in the future it would be helpful to have more of a marijuana center.
We only have time for one more question.
Yes?
This is really related to study. What part of the world was cannabis discovered and where is it invented? Do the native peoples during the study of the native people in that area with regard to their history?
To my knowledge, I guess ancient cultures thousands of years ago across the globe have been using marijuana to treat a bunch of different diseases, obviously not in a rigorous scientific way. So I don't know if I can pinpoint it to an exact country, but I do know that, I'm forgetting the exact time frame, but there was someone, a physician, I think he was British, and he went to India and he was kind of responsible for bringing marijuana treatment to the Western world. If that answers your question, yeah. I didn't look back super duper far, but that's my knowledge.
All right, thank you so much. Through Raleigh's fan base. And his thesis is titled The Angelman Approach, Hacking DNA to Treat a Rare Disease. Please welcome Brandon. Okay. Y'all can hear me? Perfect. Okay. So who here has heard of Angelman Syndrome? All right, a smattering of people, but I wouldn't say majority, certainly not too many.
And a lot of people who have heard of it are in my program or my advisor, or professors, or family. So that doesn't really count. So I hadn't heard of Angelman Syndrome until maybe a couple years ago when I found out that this girl who I'd been hanging around my entire life actually has Angelman Syndrome. So I want you to meet Alex Battaglia, there on the right, and her dad, Rich. So Alex has Angelman Syndrome, or in the preferred parlance of the community, Alex is an angel. So Alex's family has lived down the street from my own for the entire time we've lived in Maryland, 23 years now. And so she was a frequent attendee at lots of community events, block parties, barbecues, concerts, the pool, that kind of thing. And so I saw her around a lot. And I always knew that she had some sort of disability, but I never knew exactly what it was until her dad told me about Angelman Syndrome. So I want to show you just a quick video to give you an impression of Alex and just, you know, see what I've been seeing all these years. So, Angelman Syndrome was originally discovered by a man named Harry Angelman, but he originally called it Happy Puppet Syndrome, somewhat pejoratively, in my opinion. I'm glad that the name was later changed. And part of the reason that he called it Happy Puppet Syndrome originally is that angels have significant motor difficulties that can lead to problems with walking, imbalance in motor coordination, and also these kind of jerky movements, like maybe a puppet on strings. They also are completely nonverbal, or at best, in some cases, maybe they can learn to speak just a few words. And they also have this characteristic, extremely happy personality, like you saw in that video with Alex. And so between all those things, Harry Angelman decided to call it Happy Puppet Syndrome. They also have other symptoms. They are significantly mentally disabled. They suffer from seizures and also sleep disorders, sleep difficulties. Some of the parents I've spoken to who have kids with Angelman Syndrome said their kids basically don't sleep. And this is a picture of the first patient that Harry Angelman ever described with Angelman Syndrome. So there are not really any good therapeutics at this point for Angelman Syndrome, and certainly no cure. And this is partly because it's such a rare disorder that pharmaceutical companies haven't really had much of an incentive. So instead, what they do is parents will treat their kids' symptoms with drugs typically prescribed for other conditions, like anti-epileptics to treat the seizures, and sleep aids like melatonin to treat the sleep difficulties. So the man who originally discovered the gene responsible for Angelman Syndrome, this is a single gene called UVE3A. So it was discovered by Dr. Arthur Baudet at the Baylor College of Medicine, a man who's often referred to as the godfather of Angelman Syndrome. So he discovered that UVE3A, this single gene on chromosome 15, is responsible for the syndrome. And just like any other gene, you inherit 2 copies of UVE3A, one from mom and one from dad. But you only need 1 copy in your brain for your brain cells to work well. So a process called imprinting actually turns off dad's copy of the gene in your brain. But you still have mom's, so you're still good to go. Angelman syndrome results when there's something wrong with mom's copy. So now you have no functioning UBE3A in your brain, and you get Angelman syndrome. And this can cause a wide variety, be caused by a wide variety of specific genetic mechanisms, but basically they all lead to the same syndrome. Those symptoms can vary, and they all cause the same kind of really widespread effects on lots of brain processes, lots of chemicals in the brain, often in ways that scientists don't really fully understand yet, because the entire process is so complicated. But here's the thing about genetic diseases like Angelman syndrome that are linked to just one gene, like UBE3A. If you can just treat that gene, if you can fix the problem with the gene, you can theoretically correct all the consequences of that issue without knowing about all of them or understanding all of them. So, as I write in my thesis, the genetics behind Angelman syndrome are like an oil spill in the open ocean, causing an array of complex consequences that may never be fully understood. Rather than try to correct all these individual problems, the most effective strategy is just to clean up the oil, or better yet, to prevent the spill in the first place. And increasingly, nowadays, we're actually developing technology that allows us to manipulate specific genes in the human genome. So this could actually be possible. So my interest in these therapies for Angelman syndrome, these genetically based therapies, led me to the Foundation for Angelman Syndrome Therapeutics. And specifically, I was fortunate enough to attend their annual conference in Chicago this past December and speak with just a ton of people, parents of kids with Angelman syndrome, researchers, scientists. Some of these people are pictured here. I couldn't even fit them all. I talked with so many, and it gave me such a great insight into their struggles with this disorder and their hopes for their kids and their hopes for these treatments and their fears of these treatments also. I especially want to highlight Dr. Alison Berendt in the top corner there. She is the Chief Scientific Officer at the Foundation for Angelman Syndrome Therapeutics, and she was such a great resource throughout this entire process. And I also want to read kind of a funny anecdote from my thesis about the first time that I met her at this conference in Chicago. Barely an instant after shaking her hand, our introduction was interrupted by a squeal of delight erupting from behind us. A short, bespectacled woman with salt and pepper hair dashed over, wrapped Berendt in an enthusiastic embrace, and burst into tears. So you can imagine how taken aback I was when 30 seconds into my first interview of this conference, this woman is just like, ah, and then runs over and just like starts sobbing in front of me. I'm like, what have I gotten myself into? And this woman is, it turns out, I was able to extract between sobs, Donna Young, and she has a granddaughter with Angelman syndrome and had been conversing with Dr. Berendt for about a year over Facebook about ways that she can help her granddaughter, and just meeting Berendt in person completely overwhelmed her. And this just gave me such a window into the passion and how emotionally fraught this issue of Angelman syndrome is for this community. So my thesis deals specifically with two different and very promising recent approaches to treating Angelman syndrome by directly targeting the UBE3A gene. And first is called gene therapy. So gene therapy involves taking a virus. Kate talked a bit about this. You take a virus, you take out the harmful viral DNA, you put in the gene that you want to give someone, in this case UBE3A, then you introduce that virus into the person, with Angelman into the person's brain, and the virus injects that gene into the person's cells. So now the person has UBE3A in their brain, and theoretically that should go a long way to alleviating many or maybe even all of the symptoms of Angelman syndrome. And perhaps, if introduced early enough, it could even be a complete cure. So The man developing the first gene therapy for Angelman Syndrome is Dr. Edwin Weber at the University of South Florida, and he's working with Dr. Kevin Nash, an expert in gene therapy, also at the University of South Florida, and a pharmaceutical company called Agilis Biotherapeutics that specializes in developing gene therapies for rare neurological genetic disorders, just like Angelman syndrome. So, gene therapy may seem a lot like science fiction, but there's also a lot of reason to believe that it could actually work. Gene therapies for other conditions have been approved in other countries like Russia and China, and more recently in Europe. Although the FDA has never approved one for use in the United States, there's a lot of talk going around right now that a gene therapy for a form of genetic inherited blindness could be the first FDA-approved gene therapy in the US. There's also a lot of good evidence from clinical trials that Agilis has run that suggests that these gene therapies could work for Angelman syndrome. So I want to show you a video from Agilis' website of a patient with a genetic disorder called AADC that causes significant movement problems. And this patient was given an experimental gene therapy for her condition that Agilis developed. And you'll just see a marked difference. And I want to preface this by saying this is one patient. You know, science is not done with one person, so you don't know if the rest of the people in the trial experienced that kind of benefit. We don't know if Angelman syndrome would see that kind of benefit, but it does provide hope, and it gives us reason to believe that it could work. So this is the patient before receiving the gene therapy. And you can see, you know, she doesn't really respond. She doesn't move all that much. Let's get that out of bed.
Wow.
So this is the patient 12 months after receiving this experimental gene therapy. And you can see she can actually reach out for the object and respond in this way. In this part of the video, she actually just kind of looks like a normal kid. She kind of crawls around. She's able to support herself. So a similar video that Agilis showed at that conference I went to got just thunderous applause from the audience. And so I think the community is really, really hopeful about this potential treatment. The other potential therapeutic avenue that I cover in my thesis is called Antisense Oligonucleotides, or ASOs. And it's being worked on by Dr. Arthur Baudet, that godfather of Angelman syndrome I talked about earlier, and his former graduate student, Dr. Lin-Yun Meng, who is now an assistant professor of genetics, also at Baylor College of Medicine. And they're working with Ionis Pharmaceuticals, a company that specializes in creating ASO-based therapies for genetic illnesses. And ASOs are basically lab-designed DNA-like molecules that you give to a patient. They interact with your genetic material in various ways and cause various effects depending on the specific ASO molecule, the specific disease, specific genes, etc. In the case of Angelman syndrome, some ASO molecules, it was found in neurons taken from mice with similar mutations that kind of model the disease. You give them certain ASO molecules, and it actually ends the imprinting process that turns off Dad's gene. So Dad's gene is now back on. You have one copy of the gene in your brain, and that should, again, go a long way to alleviating a lot of the symptoms of Angelman syndrome. And there's actually possibly certain advantages to this approach compared to a gene therapy or maybe other genetic approaches. For one thing, ASO-based therapies have been approved in the past by the FDA for use in the United States. So, for example, one developed by Ionis for spinal muscular atrophy was actually very recently, although controversially, approved. And there's also the possibility that an ASO-based therapy could trigger fewer side effects than gene therapy or some other approach, because an ASO will activate a gene that you already have in your body, kind of a more natural copy. And so that might behave in a more natural way than kind of a lab-designed, more possibly artificial gene that you kind of give to someone via gene therapy. So it could have fewer side effects, but that's definitely all theoretical at this point. So what happens now? Well, getting a therapeutic from the research stage through clinical trials and the FDA approval process takes a lot of time and a lot of money. But Angelman Syndrome has some really critical things going for it. For one thing, the Foundation for Angelman Syndrome Therapeutics, whose conference I went to, passed, and also the Angelman Syndrome Foundation, ASF, are busy raising tons of money for Angelman research, and they're also bringing together scientists, experts in the field of Angelman Syndrome, to figure out how best to run clinical trials specifically for these patients, because those trials have never been done before. And so we need to work out the kinks before we try to do that. Also, there's an FDA policy called Orphan Drug Designation that provides significant financial incentives to pharmaceutical companies that develop drugs for rare conditions like Angelman Syndrome, and also provides a much faster approval pipeline so that we can get them to patients much more quickly. So, as I write in the conclusion of my thesis, curing the genetic disease, even one with a relatively simple single gene involved like Angelman Syndrome, takes decades of lab work followed by years of clinical trials and government review. And at any point along the way, a promising approach could be derailed by a lack of funds, scientific or industrial disinterest, unwelcome side effects, or weak evidence for efficacy in animals or human patients. But with gene editing technologies improving at an unprecedented rate, and several promising approaches to targeting the UBE3A gene being developed, a meaningful treatment for Angelman Syndrome is looking increasingly to be just a matter of time. So, thank you all for listening. Thanks to everyone watching on the live stream. Thanks so much to the Foundation for Angelman Syndrome Therapeutics and the ASF for hooking me up with so many experts and people to talk to about this, all the families that I was able to speak with, and of course, the graduate program here, my advisor Marsha, who got me this nifty DNA tie, Seth, my classmates, my professors, and everyone else. Thanks.
So I have a question for you in terms of the trials for this. Can they replicate this in animals at all, or does it exist in the animal world at all? Is there any possibility of doing trials on animals?
So Dr. Weaver and Dr. Predate have both tried their approach on animals, and that's why we think that it could work. That's why we have interest from pharmaceutical companies. So they both tested theirs on mice and kind of early versions of theirs. So it was more proof of concept. Dr. Weaver's study in mice showed that it improved learning and memory, but he was only looking at learning and memory and only actually trying to affect learning and memory because he only introduced the gene therapy into one part of the brain that's important for that. And so we don't know if it will help with other symptoms, and he still really has to refine it to try to limit side effects and try to boost its effectiveness, so get into more cells of the brain. And then Dr. Predate also kind of gave some of these ASO molecules to mice that model the symptoms of Angelman syndrome and found kind of mild improvements. But most importantly, he found that the ASOs boosted the levels of gene activity of the UBE3A gene in these mice's brains. And that's really the critical thing, he says, that no matter what happens with the symptoms in the mice, because they are still mice, not humans, the fact that it boosts the gene's activity is really the critical thing and suggests that this could work in humans. So he's very optimistic. Others are more skeptical, but the fact that there is significant pharmaceutical interest in this is really telling, because they wouldn't be involved unless they really thought it could work. They have to invest a lot in this.
In using the ASO approach, do they necessarily know, or do they know the statistics on whether the maternal copy is good as well? I mean, if the maternal copy was damaged, is there a possibility because of the way the embryo was formed that the paternal copy was damaged as well?
I mean, it's certainly possible there could be a mutation in the paternal copy that, if you turn it back on, it still wouldn't work properly. That certainly can happen. But, it's not really something we might necessarily know about. They certainly, I don't think, test like the paternal gene for mutations.
What about through the mouse models? Were they seeing where some of the mice, everything worked fine, but there may have been a few cases where it didn't work? Do you know what the probabilities were there?
I mean, I don't. When they reported statistically significant results, it was enough that they reported the results as significant. I don't know exactly what the probabilities were, and there is still really a ton we don't know about these treatment approaches and about Angelman Syndrome, and there are other genetic approaches being developed that I couldn't fit into my thesis. So, yeah, there's just basically still a lot we really don't know.
At what age? Is it fetal situation, or how young is a child diagnosed with syndrome?
Typically around age 2, I believe. So Dr. Barrett was telling me she has a daughter with Angelman Syndrome, but she also has a healthy older daughter. And so she saw the normal development of her older daughter, and when she had the younger daughter, Quincy, noticed that there were developmental delays. And she went to her doctor and was like, what's going on? And the doctor's like, no, it's normal, she'll be fine. And then eventually, you get late enough in life to 2 years old and they're still delayed, and then the doctor's like, okay, let's do a genetic test. In the case of Dr. Barrett, because she has a clinical background, she actually kind of pushed that timeline faster, but for a lot of parents, it tends to be maybe around 2 years of age.
So I don't know much about genes, but one of the things they do, right, is they transcribe the genetic material into some kind of protein that actually has functionality in the body. So have they figured out what it is that this particular gene constructs in you, and is that another avenue for treatment to just introduce that particular protein?
So yeah, the gene actually, in the end, ends up creating a protein that is also called UVB Predate. And I have not heard of any people thinking about just creating the UVB Predate protein and giving it to the brain. That could work. It might be difficult because maybe, figuring out the levels exactly might be tough to do, versus if you kind of put in the gene, maybe it'll produce it in the right levels without you having to really know what those levels are. So that's a really interesting idea. It wasn't something that I heard very much about.
Just to follow up on that, it's often really hard to get a protein into the cell and it doesn't last very long. So probably the reason they're not. So the question for you is 2 years early enough that gene therapy or ASO would have an effect, or if you have this cure without the push diagnosis of cure?
Yeah, I mean, so some people talked about the advent of kind of in utero genetic testing, and if this was tested for in utero, and which would have to involve the prices coming down substantially, but that definitely will at some point happen. Yeah, so I mean, if you know in advance, you could potentially start treating as soon as they're born. maybe even in utero, I don't know. But the thing about it is that it's not developmental. So for the most part, we think that their brains are normal. There's evidence that there are some differences in their brains, but that it's really a chemical issue. And so if after they're born, you start treating them immediately or soon, then you might see a really, really marked effect. And certainly everyone kind of consistently says that the earlier you would treat, the better they would end up. But yeah, certainly diagnosing earlier would definitely be a help. And back to the protein question. So Dr. Weaver is actually considering an approach where, interestingly, so Bennett, you mentioned like it's difficult to get proteins into cells. So he wants to kind of create a gene therapy where the gene will basically enter a few cells. Those cells will become factories that make the UVB protein using that gene. And then they'll kind of parcel them and ship them out to other cells. And the other cells will like take them up rather than having the gene themselves, I think. So I think he's kind of working on a way to kind of have the brain kind of, in a way, do what you're talking about. Yeah.
This is fascinating and exciting, but perhaps just because I'm getting older and more cynical, I recall the statement from a lot of cancer researchers: they can cure almost any cancer you want in mice, and we know the impact that has had on human disease. So I'm wondering if you were to sort of, kind of flip the switch in your head and make the most skeptical account of this approach. You finished your presentation by saying that the real treatment and a cure is possible and maybe sort of imminent. What are the things that would stand in the way of that from what you've learned during your process?
Yeah, it's really interesting that you say that, because my first exposure to this, when I heard about it from Rich Battaglia, Alex's dad, was, that this was like, this could be a cure, and this is really, it sounded like it was really far along, and that there was like a lot more certainty. And the first person I spoke to was kind of really excited about this and was like, yeah, this was a cure in mice, like they saw a cure in all symptoms. And then I actually talked to the researchers and people more directly related to the science, and of course they gave me all the caveats and like, well, actually, and I like read the scientific papers and was like, oh, they saw mild improvement in a couple of symptoms, not a complete cure in all symptoms like this person told me. So in terms of why might this not work, I mean, they tested it in cells and they tested it in mice, and neither of those things is a person. So people are complicated, and the gene is not exactly the same in mice and in people. So there's definitely translational difficulties there. There's also a lot of interesting studies going on, though, to develop more animal models of Angelman syndrome. So not just mice that have these UBE3A mutations that emulate Angelman syndrome, but animals that are closer to being like humans, so pigs specifically. And if we had, pig models of Angelman syndrome and it worked for them, that might be much stronger evidence than just mice.
All right. Thank you so much.
The full quote is, "We can cure cancer."
Okay. We have two more fantastic presentations left. Coming up next is a presentation by Greta Fryer, who, in addition to being a fantastic student, is also from my hometown, and is a big Red Sox fan like I am, so it makes me love her all the more. And her thesis is titled "Ghost Forests of the Mid-Atlantic: How Sea Level Rise is Killing Our Coastlines."
I'm going to preface this by saying I have a cold, so thank you in advance for bearing with me if I have a coughing fit while I'm talking. Yeah, so my thesis is on ghost forests, which are the increasing number of dead trees along the edges of tidal waterways, like the ones that you can see here, which are in New Jersey. And these trees are being killed off by sea level rise due to climate change, and it's become an increasing problem all along the East Coast. And so the trees are, in a sense, a canary in the coal mine for climate change. And when you start seeing these ghost forests, there's a lot more really problematic changes coming. So I'm going to talk a little bit about what those are. I first learned about ghost forests at the Daniel Webster Wildlife Sanctuary in Marshfield, Mass. when I was on a bird watching trip. And we were walking along the boardwalk through the sanctuary and came across this area that was just full of these dead trees in sort of a swampy area in the middle of, a really nice spring day. And it was really startling when you see it in person. And then the sanctuary manager who was leading the bird watching tour referred to it as a ghost forest. So standing there, I had the same reaction that I think people have when they first see a ghost forest in the wild, which is, what is going on here? And so I decided to set the opening of my thesis with sort of a similar scene of someone having that experience, but I actually couldn't use my experience with this forest because it wasn't killed by sea level rise. It's an anomaly. It was killed off by a dam, which redirected water flow into the plain where the sanctuary is. So I set the opening of my thesis in a ghost forest in North Carolina, and I'm going to read an abridged version of that. It's a beautiful day in the Palmetto Pear Tree Preserve in North Carolina. The sun-soaked beach of the Albemarle Sound is warm, but the breeze rolling in across the water is cool, with a hint of salt. Gentle ripples lap at the shore, making indents in the sand. A few feet back from the water, bright green marsh grasses rustle in the breeze, and farther inland, the fern-like foliage of cypress trees casts its shade. But there's something out of place. A pair of dead cypress trees stand in the sound, several feet out from the shore. The thick pyramidal bases of the trees emerge from brackish water, and a ring of damp, dark bark above the waterline reveals that the tide is receding. The narrow trunks curve up into broken leafless branches. Nearby, the water breaks around jagged stumps. More trees grew here once. Cypress trees cannot germinate except on dry land. So when these trees were seedlings, the places where they are standing must have been dry. Now they are covered by water. This raises a question that local scientists want visitors to ask themselves. Why? And the answer to why is sea level rise. So due to climate change, global sea level is rising by around 3 millimeters per year, which is the fastest rate in thousands of years, and it's accelerating. And even though they live near the coast, coastal forests are freshwater systems. So as sea level rises, salt water travels through all these tidal waterways, and not only does it kill off the trees that are right on the beach, but the salt water can reach miles and miles inland during high tides and kill off trees 10 miles from the coast. So cypress trees and cedars, which are the trees that tend to be in ghost forests, are actually pretty hardy. It takes water 1/10 the salinity of seawater to kill them. Most vegetation will die off long before that. And so before you see a ghost forest, what you see is a forest with all the vegetation dying. And then the seedlings will die because they're younger and more sensitive, sort of like babies are. So the forest is actually already doomed, but when you get a ghost forest, it's long past saving. And sea level rise is a particular problem in the mid-Atlantic region because not only is sea level rising here, the land is sinking. So that's mostly because during the last ice age, there was a thick sheet of ice across most of the continental US, and the weight of the ice pressed the land in the center of the continent down. And then the land on the east coast, which didn't have ice on it, was at the same time sort of pressed up. And the ice has melted, readjusting, and so the center of the country is rising back up, and the land on the coast is sinking. Exacerbating that is human interference. So through things like draining groundwater, when we drain groundwater out of aquifers, the land sort of compresses around that area, and there's even more sinking that happens. So as tends to be the theme of this, people are messing everything up. So coastal forests are part of a larger series of ecosystems that are affected by sea level rise, so it's not just the trees. Marshes that live in front of the coastal forests are also affected. So the trees are the most sensitive, and what tends to happen is that after the trees die off, the marshes, which are also under pressure, will retreat back into the space where the trees are. So when you see a ghost forest, what you might actually see is a bunch of dead trees surrounded by marsh plants, which is a little unsettling when you see it, a little confusing. But that's what's happening, because the marsh plants are migrating inland to escape from sea level rise. And then the sea level will keep rising and kill off even those marsh plants, and that's when you end up with these tree trunks that are standing in open water, like the ones from North Carolina. And most people really don't spend a lot of time thinking about marshes, but they're actually very important. Not only do they hold a lot of different types of wildlife, but they're the home of 75% of commercially fished species, the fishing nurseries and the places where the young fish will feed. So even if you don't necessarily care about endangered animals, if you like eating seafood, then it should matter to you that marshes are disappearing. But if you do care about endangered wildlife, there's a bunch of species that are threatened by the disappearance of both the forests and the marshes. These are a few of them. That's a salt marsh sparrow and black rail, which are birds that are getting harder and harder to see in the marshes. That's a Delmarva fox squirrel, and that's a red-cockaded woodpecker. And they're also both very dependent on coastal forests. So another problem, as the forests and the marsh are dying, is that both of those systems are really good at sequestering carbon. And so while they're alive, they actually help to fight climate change. And as they die, some of the carbon that's being kept there is released back into the atmosphere, and you get this positive feedback loop for the more climate change you have. Sea level rises, it kills off the ecosystems, they release carbon, you get more climate change. It all sort of spirals out of control. Sea level has actually been rapidly rising, also since the last ice age, but at the slow speeds that it used to be, it wasn't a problem for trees or the marshes. And so what used to happen for thousands of years was that as the sea level would sort of inch up the coast, the trees and the marshes would have time to shift their ranges inland. So sort of like how I talked about the marshes migrating into the ghost forests. What used to happen is that the forests would move first inland, and then the marshes would follow them, and then the sea level would follow them. And they could kind of just go on forever because they had the entire United States. But then people showed up. And so now the trees and the marshes migrate inland until they hit human development, like towns or like highways, and then there's nowhere else for them to go, and the sea level keeps rising. And the trees and the marshes die because they're trapped in a space that's getting smaller and smaller. So this is referred to as coastal squeeze. So again, not only are we responsible for the accelerated sea level rise, but we're helping to kill them off in many other ways, including not only coastal squeeze, but the construction of dams, which can kill off forests like the one that I saw in Massachusetts by redirecting water flows, and can kill off marshes by redirecting sediment, and marshes need sediment deposition from water flows to help them build elevation. And then along with dams, we've also introduced a bunch of invasive plants to the mid-Atlantic, and these are taking over the places that the marshes and forests would have moved to. So in particular, there's an invasive marsh species called Phragmites. And when I said you can see marsh plants growing in ghost forests, what you usually actually see is Phragmites, which we don't want because it's mostly uninhabitable for a lot of these native species that need the marsh. It's really aggressive and kills off native marsh and doesn't provide as many of the ecosystem services. So there's all sorts of problems facing these ecosystems right now. And the other thing that's happening is, as you can see, the water's not only affecting marshes and trees, it's becoming an increasingly big problem for coastal communities. So this image isn't even like a flood, this is high tide. And this is what the people in this house live with now. But in most towns so far, high tide is not the problem is storm surges. And the reason why sea level rise affects storm surges is because the baseline of the ocean is higher, and so the amount of water that you get during a storm has a higher baseline, and the East Coast is really level elevation, so a small vertical increase in the amount of water will reach really far inland and flood much, much further into the towns and cities. And when you have trees and marshes in between the sea and the town, they're really protecting against storm surges. So first of all, they both absorb a lot of water. And then secondly, the plants, the roots prevent erosion of the soil. And then as really violent waves move through the plants, the waves are buffered and slowed down. So the water that's really violent as it's pouring in through the friction of moving through all this vegetation will slow down and be easier to manage by the time it reaches towns. And then on top of that, marshes actually build elevation to help the coast keep pace with sea level rise. So they do that through sediment deposition, which I mentioned earlier. As the sediment moves through the marsh in water, it settles out of it, and that builds up land that helps the coast keep pace with sea level rise. And then also, marsh plants make a lot of roots, and so as those sort of compost, they build up biomass that also helps to build up the soil. So somewhat ironically, a lot of these towns that are starting to have problems with storm surges and flooding are putting up these seawalls to try to prevent flooding from impacting the towns. And what it actually does is it kills off the marshes, because the same coastal squeeze that I was talking about happens, where the marshes hit seawall. They have nowhere to go, they die. And so by putting up the seawall to prevent flooding, these places are killing off their really amazing natural system of flood protection. And long term, perhaps creating a bigger problem for themselves. And this is a calculus that towns really have to do right now, because sea level rise is already causing billions of dollars of damage to coastal towns. And one of the things you start to really realize when you study coastal forests and coastal ecosystems is that sea level rise is not this abstract thing, and climate change is not this far off thing that's happening to glaciers that are melting somewhere in Antarctica. It's here, it's happening right now. And there's already communities living in the mid-Atlantic that have had to be moved. So not only are the forests migrating and the marshes migrating, but now people are going to have to start migrating inland as sea level rises. It's just like a placement issue. Sure. Is that good?
Good.
Cool. I'm going to use that as an excuse to also drink some more. So as I was saying, people are also now going to have to start migrating inland. And this is a decision a lot of people are having to make right now, because they live in towns that are not quite uninhabitable, but where during storms or during particularly high tides, the roads leading into and out of the towns will be flooded, and there's no way in or out. So no one can get to school, no one can go get groceries, emergency services can't get to you. But you've been living there for generations. Do you stay or do you go? And by the end of the century, that's the sort of decision that a lot more people living on the coast are going to have to make. So the scientists who study ghost forests are hoping that because they're so visible and sort of startling when you see them, you see this and you can tell right away that something is wrong here. That people will start paying more attention to sea level rise, because this is a huge problem, and it is here now. And in spite of that fact, the Trump administration is openly hostile to climate change research and shutting a lot of it down. The database is down, and local governments also don't pay that much attention. Scientists that I talk to in places like North Carolina, where climate change is really a political issue, are very frustrated by the fact that their work is sort of constantly shut down and not listened to because of these political battles, and in spite of the fact that it's actively causing problems for the ecosystems and for the people. So the hope is that one upside of ghost forests is that all of these trees dying will catch people's attention. So once people notice everything that's happening, what can we do about it? Not that much is unfortunately the answer. Sea level rise is happening, it's accelerating, and it's at the point where we can't stop that. So the landscape of the East Coast is really different now than it was 50 years ago. The trees, sort of where there used to be forest, the trees will move back. That's marsh or open water. And that's going to keep happening. The coastline is going to disappear. The ecosystems are going to shift. The animals that we see are going to change. And not only local animals, but a lot of migrating birds from the tropics use these forests to roost in as they move up to Canada. And so no one knows exactly what's going to happen to them as their sort of migration grounds disappear. And essentially at this point, that's a fact of life. Long-term, the only solution is to try to mitigate climate change to keep sea level rise from accelerating more than it's already going to. But for a little bit of hope and optimistic note on which to end this presentation, one solution is to create migration corridors. And so the land managers who own protected parks where these ecosystems are have stopped buying up land that has the forest and the marsh in them, and have started buying these strips of land that are perpendicular to the coast, heading inland through human development, where the forest and the marsh can migrate. So they're trying to recreate, what used to be the natural solution, places for these ecosystems to migrate inland, and the hope is that that will have some effect, at least for a while, depending on the rate of sea level rise. Forests could just drown in place. It takes a while for forests to migrate because they have to do it via seedlings. Trees can't actually walk away. But more and more land managers along the mid-Atlantic are starting to use migration corridors, and hope that that's going to be a solution. And so I'd like to thank also all the professors in this course, my thesis advisor, Toby Lester, who's not here. He's picking up his daughter from college today, which I think is an understandable excuse. And all my classmates, and of course Shannon. So I'd be happy to take any questions.
So I loved your talk, and this is a catastrophic situation. No pressure to that in my mind. So I'm going to ask you a hard question.
Okay.
Because this is a personal issue. So I'm going to remove it from the catastrophe that's coming, and I believe in it. And my personal thing is this. I actually am thinking very seriously of buying a house on a small island off the Gulf Coast. Okay? On the 100-year floodplain, you look at the maps, it's rose red, and I've been looking at it like crazy to determine if the house is going to be underwater. Okay? And your slide even says, this is concerned scientists. This is potentially destructive. There is a risk of flooding. So my basic question is, and I know it's a very selfish question, and I endorse it faster. But what's the probability of this affecting me if I buy a house and it needs to last like for 50 years and maybe transfer to my kid? How do I think about this mathematically probabilistic? 100-year floodplain is just that. Once in 100 years, it floods. And that's probability. So how do I think about this?
Yeah, I just read an article in Reentry the other day, which is that the scientists advise in order to prevent flooding, people should stop buying houses in floodplains. It keeps happening because people want houses on the coast, and so that's very attractive. And the answer is I would recommend you look at NOAA models for the particular area where you want to buy a house, because there are scientists who are modeling the specific flood patterns that are going to happen along different areas of the coast. So I don't have the answer myself, but there are models out there. And they're the same models that people are using in order to figure out what land to buy for these parks. They look specifically at places where the flooding is expected in the next 100 years or not. And they have, I think, pretty good prediction models. So instead of just using sort of the generic, this is an X year floodplain. Yeah, I would look for a more specific model that is for the place where you're looking at a house.
Okay. Do it.
Yeah, I know how it goes.
So apart from this being a problem, what would you say is the biggest problem with climate change?
Apart from flooding or sea level rise?
Yeah,
I mean, that's a big question. And there's so many factors. I think the biggest problem is that we don't know what they all are. And to a certain extent, it's the fact that there's so many unknown factors and unexpected things that happen. And so what ends up being really disastrous is probably going to be the problem that we miss because we won't be prepared for it. But you can point to plenty of examples. So parasite ranges are changing. So as the temperature levels shift, parasites that never used to attack the trees in the mid-Atlantic are moving north. and that's another huge problem, that you get these beetles that just eat all of the trees. The same thing with diseases are moving as well, and so you get all these diseases that kill the trees or the animals or the people. I mean, there's sort of a million different problems, I guess. It's hard to pick just one. But I think if you live on the coast, sea level rise is a really big one to be thinking about, because you might not be able to live on the coast anymore, and it doesn't really get more immediate than that.
It's my understanding that I think like squirrels plant like a bunch of like millions of trees a year. And with this, like I remember you said in your presentation that squirrels would be the first ones affected. So like what animals that wasn't on the presentation that you think are going to be affected by coastal flooding?
It's hard to say. I mean, animals that aren't obligates of salt marshes or coastal forests, so animals that can live in multiple habitats, have places to go to. So you might have deer that are living in a coastal forest right now, but they can just move to another forest further inland. So marsh species, to a certain extent, are probably at bigger risk than a lot of the forest species, because once the marsh disappears, there's nowhere else for them to go. And again, it's even not species that you would think of as marsh species, but ocean species, because fish have their nurseries in the marshes. And so even if they don't spend most of their lifespan there, if they don't have nurseries, they die. As for birds, I think the migrating birds are going to have a problem, because they really don't do so well, and they have to adjust their really specific migration patterns. And I would be particularly concerned about them, because a lot of birds also have very specific niches where they feed off the insects that feed off of a specific plant. And so if those plants die, or if those plants are replaced by invasive plants, then those insects disappear from that area, the birds disappear from that area. And so sort of the more particular that the species is and its habitat needs, the more at risk it is. Yeah.
So is salt intrusion into the aquifers also affecting the plant?
It is. I have not studied that as much, but it definitely is a problem that there's salt water that's also getting into our drinking water and into farmland. So a lot of farmers are really interested in this research when very few people are actually paying attention to it, because they want to know, is the land that I'm buying up for my farm or for my timber plantation going to have salt water intrusion in the ground? And that's what it is. Yeah.
So, I've read recently that there are places like Florida that, in Miami, for example, they're literally building all the roads. They're elevating them 6 inches or some half a foot in order as a counteroffensive to the rising sea level. My question is are these type of efforts by the coastal towns fool's errands?
I think probably yes. I mean, a more fair description would be their short-term fixes. So if what you're trying to do is just hold off the water for now, then that's fine. You get 6 inches worth of leeway, and that might take you to the end of the century. And if you don't care that much about what happens to your grandchildren living in that town, then you're good. But if you want to look for long-term solutions, you can't just keep raising the highway by 6 inches and another 6 inches, in part because that costs way too much money. And people who pay for that are mostly broke. FEMA is in a ton of debt. It's flood insurance after the bad hurricanes that we've had in the last decade is just gone. And also because sea level rise is accelerating. And so what seems like it's going to be an okay solution for now is it's going to have to keep pace with the rate of acceleration as well as with the current rate.
Is there evidence of sort of bilateral cross-contamination? So as the water creeps inland, it brings salt, and salt contaminates the ground, and then that limits what grows in various ways. But as the water goes further in, does it in turn also take back when the tide goes back out, or just generically from mixing sort of, highway runoff and toxins that are in the land and get them back into this very sensitive environment?
It does, and actually a big problem that I didn't talk about at all is that saltwater intrusion impacts trees' ability to soak up the nutrients from their leaves. And so usually what happens is that in the fall, before deciduous trees shed their leaves, they suck up all the nitrates and everything into their trunks to use for the winter. But if they're affected by saltwater, they're really bad at doing that. And so they drop all of this leaf litter that's full of nitrates, which is what all organic things thrive on. And those nitrates end up in the water stream, and they can cause huge algal blooms back out in the water. So there's a bunch of different chemicals that are sort of showing up in the water, in the marshes and also in the ocean and causing problems. I mean, and that's a natural example, but I'm sure the same is true of toxins, but maybe sort of man-made.
Time for one more question, Tyler?
To what extent is just, I want to say climate change, like a natural phenomenon that was going to happen either way? I mean, I'm very familiar with like Cape Cod and how it's like this, peninsula, and, people who own property and live on Cape Cod, recognize that, especially the outer Cape is constantly shifting, on account of just winds, tides, just all different forces of nature against the Cape. And so it's kind of shifting, they kind of map different trends and stuff, but I mean, not necessarily like a negative thing. I mean, the Cape is kind of just accepted that is part of being a Cape Cod, especially on the outer Cape, that, that climate change will just, or just forces of nature will cause the Cape to shift. And I mean, like, I don't know, the dinosaurs died out because of climate change, and that was before people were even there to really be involved in, causing climate change.
I don't know if that's an optimistic model, though. Mass extinction, no diggity. I mean, I think so. As I discussed, sea level rise has been rising gradually since the last ice age, and sea level rise has gone up and down for eons. I mean, that's just a pattern. And what's problematic now is the rate at which it's happening. And so, the small changes that used to happen to the coastline and that will always happen to the coastline are fine, and all the ecosystems can keep pace with those. But when it's as accelerated as it is, which if you look at the models, there's pretty strong causal links to human activity. If you look at the Rutgers Sea Level Research website, they have some studies like that. So those human links are causing the rate to accelerate far beyond what is normal. And the damage that it does is a lot worse than sort of your year-to-year, century-to-century variance. So having a little bit of sea level rise and then everything shifts over, fine. Having enough sea level rise that your entire ecosystem disappears and all those species disappear is a problem, and one that can't really be solved. And the outcome ends up being extinctions, which I think most of us probably personally don't want to go extinct and would care. Again, if you care about animals, you care about them going extinct. If you like eating animals, you also care about them going extinct. So there's plenty of reasons.
Not sure I know.
So, for our last presentation, we are moving from problems with life on our planet to life on other planets. The final presentation of the day, and the final presentation for what, again, I need to stress is really an exceptional class, is Maria Temming, and her thesis is titled Melvin Calvin, Nobel-winning chemist and SETI scientist wannabe. Maria.
I talk with my hands a lot, so I'm afraid to whack it off. So, hello everyone. Thanks for sticking with me until the bitter end. So, as Seth said, my name is Maria Temming, and I am here today to present on Melvin Calvin, Nobel-winning chemist and SETI scientist wannabe. And just to kind of give a little bit of background as to how I came to this particular thesis topic, I want to start by defining one of the terms that's in the title, for anyone who's not familiar with, sorry, this is the end. Take two. Defining one of the terms that's in the title, which is SETI, which for anyone who's not familiar is the search for extraterrestrial intelligence. And this is a scientific endeavor that's been going on for the past half century or so that involves looking for aliens, or more specifically alien signals, primarily using radio telescopes. And this modern scientific search has its roots in a 1959 Nature paper that was published by Giuseppe Cogney and Philip Morrison. And essentially what these two Cornell astrophysicists were arguing was, hey guys, radio telescopes have gotten advanced enough that we could feasibly use them to look for aliens. So someone should totally do that. And little did they know, someone was already totally trying to do that. And this was Frank Drake, who is a young astronomer at the National Radio Astronomy Observatory, conducting what he called Project Ozma, which was the first ever SETI search. So he was using this radio telescope to look at two nearby sun-like stars, hoping to tune into some alien radio broadcasts. Did not pick up on any, bummer, but he was approached by National Academy of Sciences biologist James Peter Pearman. And Pearman said, you know, your Project Ozma and this Nature paper that recently came out have gotten some significant public attention, understandably, and some attention from the scientific community. So now that this whole looking for aliens business is transitioning from the purely speculative more towards the scientific, I think that we should host a conference about this and bring people from different scientific backgrounds to weigh in on, you know, what they think about life in the universe and how common it might be and what it might be like, and therefore how we might best try to contact it. So over the next several months, Pearman and Drake go back and forth hashing out all of the details for this meeting that they want to host. And they decide a couple of things right off the bat. One, they want to host it at the National Radio Astronomy Observatory, where Frank Drake conducted Project Ozma. Two, they do not want any press coverage of this event, because it's going to be a bunch of people hanging out talking about aliens for 2 days. And they don't want to risk undercutting anyone's scientific ethos in their own communities if they're concerned about that. So three, they also decide that they're only going to invite a select small group of people who they think can contribute most substantially to the conversation at this meeting. And that was, you know, A, to keep it as innocuous as possible, but also B, because this is what the National Radio Astronomy Observatory looks like in the early 1960s, not exactly a prime conference venue. So since they can only have as many people as can stay in the tiny dormitory and a couple of farmhouses on campus, they send out a couple dozen invitations in total, and these are the 10 scientists who show up to this first ever conference on the search for extraterrestrial intelligence. And so this has been kind of the basis of an ongoing project for me, wondering about who these 10 scientists were that got this invitation to come talk about aliens for 2 days out in the middle of nowhere, West Virginia, kind of in secret, and we're like, yeah, no, that sounds like my cup of tea. So this has been an ongoing project, profiling these 10 scientists, A, looking at who they were as scientists in their own fields, and what they contributed that gave them enough name recognition that they were put on the invite list, and also B, what they have since contributed to the scientific community's thought on life in the universe. So this year, Seth has been forever encouraging me to get out of my space science bubble. So as much as I can do that while still talking about aliens, I picked Melvin Calvin, who was a UC Berkeley biochemist who attended this meeting. So when we all dispersed to go do our on-the-ground reporting in January, I was very excited to escape Boston in January and go to the Bay Area, where it was rainy and cold and horrible the whole time I was there. But that was okay, because I spent most of my time anyway in the Bancroft Library at Berkeley, pictured here, which is where Melvin Calvin, when he passed away in 1997, left a lot of his personal writings. So correspondence, you know, pre-publication versions of papers, etc. So I got to spend a whole week snooping around in Melvin Calvin's stuff, which was pretty neat. So this is one picture of Calvin that I found while I was in the archives there, which I think is pretty representative of him in his later years. He was a huge fan of tweed. And so he's pictured here in front of a bookcase in his office where he's got some photos and texts, etc. So just to kind of introduce Dr. Calvin to the group, when he was growing up in St. Paul, Minnesota and Detroit, Michigan, he was a total science dork from the very beginning. He was one of those kids who really liked to take apart his toys and put them back together to see how they worked, and like joined the birding club with his one friend. And in high school decided that chemistry was the topic that he wanted to home in on as his scientific area of interest. but was in fact told by one of his high school science teachers that he would never make a good scientist because he didn't, quote, collect all the data, which just meant that this particular teacher was very frustrated with Melvin Calvin shouting out these half-cocked answers in the middle of class without really having thought things through, and being very cocky about it. And this particular anecdote came up a laughable number of times in all of the interviews with Calvin that I read. And typically it would be followed up with this section of Calvin trying to explain himself, like this section from a 1984 interview. So this is after his retirement, where he says, "I have since told my students that there's no trick to get the right answers when you have all the data, just the computer can do that. The trick is to get the right answers when you have only half the data, and half the data you've got is wrong, and you don't know which half is wrong. Then when you get the right answer, you are doing something creative." Which tells me two things about Dr. Calvin. One, that he was always kind of intellectually primed to go into fields as speculative as astrobiology and SETI, and two, that this dude could fixate on something for a really long time. So Calvin does indeed go into chemistry. He gets the first ever Bachelor of Science in Chemistry from the Michigan College of Mining and Technology. So since he's at this mining school, all of his electives are earth science classes, like paleontology, which gives him this great appreciation for the long trajectory of evolution over the course of Earth's history. It starts to kind of plant these seeds in his mind of wondering, so how did that trajectory of evolution get started in the first place? So he follows up his BS in chemistry with a PhD from the University of Minnesota, does a brief postdoctoral fellowship at Manchester, and then gets hired on as an instructor at UC Berkeley, which is where he spends the rest of his career, and goes on to become a very esteemed lab director, and has a building there named after him to this day. So Melvin Calvin, pictured here working in his Berkeley lab, his primary claim to fame as a biochemist was his work on photosynthesis, which he did from the mid-1940s to the mid-1950s. And he was kind of thrust into this particular line of inquiry because one day in 1946, when he was coming back from lunch, Ernest Lawrence, who was the founder of the Lawrence Radiation Laboratory, where Calvin was then director of the bioorganics chemistry group, came up to him and said, "Look, I have all of this radioactive carbon stashed away in my lab, and I want to get rid of it, so I'm going to give it to you. Go take it and do something useful with it for research. I really don't care what, I just want it out of my lab." And so Calvin has all of this radioactive carbon that he doesn't know what to do with, but when you work in the Ernest Lawrence Radiation Laboratory and Ernest Lawrence tells you to do something, you have to do that thing. So he decides eventually that he's going to use this radioactive carbon to map out the path of carbon in photosynthesis. So, context. This had been a long-standing mystery in biochemistry of how do plants actually take the carbon dioxide that they get from the atmosphere and use the carbon part to help construct carbohydrates. So what are all the intermediary molecules in that process? And this had been a mystery because once carbon dioxide is subsumed into the plant cell, it's really difficult to distinguish that carbon from the carbon that is already making up the organism. So Ernest Lawrence's radioactive carbon offers this very clever workaround because it can do everything that normal carbon can do in terms of being processed through photosynthesis, but it also gives off radioactivity, which makes it very easy to spot in different molecules. So for each trial of their experiment, Calvin and his colleagues would feed this flask of algae, this carbon dioxide that was laced with radioactive carbon. And then after some pre-designated period of time, they would kill the algae. And using a technique called paper chromatography, they would be able to separate out all of the dead algae's molecular components onto a piece of paper, and then scan that piece of paper with a device designed to detect radioactivity to pick out which molecules had radioactive carbon in them. So if you have all of these dead algae samples that have been killed after different periods of time, you can use them to create kind of a time lapse to show how this radioactive carbon from the carbon dioxide crops up in one molecule, and then another, and so on down the line until you have carbohydrates. So mapping out this whole process of the path of carbon in photosynthesis takes Calvin and his colleagues over a decade. But finally, ta-da, they have the magnum opus of Melvin Calvin's biochemistry career, which is known as the Calvin cycle, or the Calvin-Benson cycle, if you want to give more credit to one of Calvin's colleagues. And so this earns Calvin international acclaim in the biochemical community. It's kind of a cornerstone of photosynthesis research. It gets him the nickname Mr. Photosynthesis in Time magazine in 1961. And so, it's a decade's worth of work. He's very proud of it, obviously. It's so nice. But this Calvin cycle leaves Calvin with a really big, lingering question, which is basically, this is crazy complicated, and Calvin could not possibly imagine that this is how life got started on Earth in the first place. So he was nagged by this question of, what did get started, or what did kickstart life on Earth, and how did it develop to sustain and depend on these exceedingly complex processes? So the prevailing theory at the time was that billions of years ago, some source of energy, either cosmic rays from outer space, or the sun's UV radiation, or maybe lightning, somehow injected some energy into a body of water on Earth that had simple molecules in it, and tore the molecules all up, and forced the fragments to rearrange into these simple organic molecules that would become the building blocks to life as we know it. So this is kind of known as the primordial soup theory. And so Calvin was wondering, can you simulate that sort of event in the lab to give credence to this primordial soup theory? So in 1950, Calvin, still kind of in the middle of his photosynthesis enterprise, tries to perform this sort of experiment in a lab. So this is his recipe for primordial soup. So to imitate the early Earth's ocean and atmosphere system, he fills a flask with carbon dioxide, hydrogen, and water, and then zaps those ingredients with high-energy radiation from the lab's particle accelerator. And he was able to synthesize some simple organic molecules, which was encouraging, but not super groundbreaking. So he and his colleagues write it up in Science, like you do, and publish it. And soon enough, Calvin gets a visit from Harold Urey, who is a researcher from the University of Chicago, who is also interested in the origins of life. And Urey says, I think what went wrong with your experiment is that you have the wrong ingredients for your primordial soup. I think that instead of using carbon dioxide, you really want to imitate early Earth. You should have been using methane and ammonia instead. And sure enough, in 1953, Harold Urey and his doctoral student Stanley Miller come up with their own primordial soup experiment. And instead of using high-energy radiation from a particle accelerator, they use electricity. And they're able to brew up some amino acids, which build proteins, which are very important to life as we know it. So the Miller-Urey experiment goes down in history as this groundbreaking sort of Genesis in a bottle experiment, and Calvin's experiment fades into obscurity. Sad. But this did not stop Melvin Calvin from wondering about the origins of life on Earth, and the origins of life elsewhere in the universe. Particularly because Melvin Calvin was pretty well read on the writings of astronomers like Harlow Shapley, who had estimated the vast number of sun-like stars that were thought to populate our galaxy and the vast number of potentially habitable planets that were thought to orbit those suns. And so by the mid-1950s, Calvin was really of the opinion that, quote, there must be other places like ours out there and we've got to go find them. So he felt very passionately about this and really wanted to help with this whole search for life in the universe question that he found so fascinating. But he also struggled with the fact that he was not an astronomer, he was a chemist, and so he felt like he didn't really have any research to contribute to this particular area. So he struggled with this for a long time, and then in the late 1950s realized that, okay, so if you're not an astronomer who can study things in outer space, Calvin, you are at least a chemist who can study the pieces of outer space that have crash landed on Earth. So Calvin decides that he's going to take up studying meteorites in hope that they might hold some clues about the potential habitability of other places beyond Earth. So he sends out this flurry of letters to museums all over the world, from Chicago to London to Paris to Moscow, begging, please, please, can someone send me some meteorite fragments to study? And gets shut down a lot of times because people are very covetous of the meteorite material that they do have. But finally, he gets some material from the Smithsonian Institute in DC, from the Murray meteorite that crash landed in Kentucky. And so he and a colleague start scrutinizing this, and in 1960 announced that the meteorite had a sad lack of microbial hitchhikers on it. But this really didn't deter Calvin. He was still very interested in this question of life in the universe. So when he, the next year, got an invitation to attend this first ever SETI conference, he very eagerly agreed. And so Calvin rolls up to Green Bank with his young friend and colleague Carl Sagan, who's been at a conference with him in DC. And Frank Drake's first impression of Melvin Calvin is kind of twofold. One, he thinks that he's super nice, very warm, very cordial. Drake is very glad to have him. But also, two, he's kind of amazed at how well Calvin is holding it together, because the rumor mill in the scientific community has it that the 1961 Chemistry Nobel Prize is going to go to Calvin for his photosynthesis research. And the winner is going to be announced in the middle of this Green Bank meeting. But Calvin is very calm, cool, and collected, They go on and they have their meeting. It's unclear what explicitly Calvin contributed to the meeting because no one recorded the proceedings. But on the program, at least, it says that he was there to present his origins of life research and weigh in on the biological considerations concerning the possibility of aliens developing human-like intelligence. But whatever Calvin said during the meeting, he probably left his most significant mark on Green Bank in the wee hours of the morning on the second day of the conference. So I want to read from my thesis for you now regarding that particular event. So all the scientists had long retired to their quarters in the residence hall and farmhouses clustered on the observatory campus. Around 4 a.m., the dead silence of Green Bank was shattered by a telephone ring in the administration building. It was the Karolinska Institute in Stockholm, Sweden, to announce that Calvin had been awarded the Nobel Prize in Chemistry for elucidating the path of carbon in photosynthesis. The guardsmen dashed across the dark grounds to the residence hall and shook Calvin awake to give him the good news. Of course, it wasn't long before everyone else was out of bed, too. They broke out the spirits that Pyramid had purchased in anticipation of this merry occasion, toasted Calvin, and then, as Sagan so eloquently put it, got smashed on champagne. At some point in the midst of all this fraternal merriment, the conference attendees collectively dubbed themselves the Order of the Dolphin, in honor of the closest proxy to alien intelligence here on Earth. So, the Order of the Dolphin never meets again after this first ever SETI conference. Some of the attendees kept in touch with one another. Calvin made some good astrobiology friends, but it was never a sustained society, which is too bad because it's clear that Calvin really wanted it to be this ongoing club with his astrobiology bros. And we can tell this from his writings, but also because the week after Green Bank, he went to go give a series of lectures at Harvard, and there he inducted new members into the Order of the Dolphin, designated them the Boston chapter, and then commissioned them to have these pins made for everyone who is at Green Bank, which Pyramid has since turned into a necklace, that has this picture of someone riding a dolphin on the front and has everyone's names and the date inscribed on the back, which is super cute. So Calvin does continue on with his life in the universe research after the Order of the Dolphin conference. Throughout the 1960s, he keeps studying meteorites. And now that he's a Nobel winner, he actually finds that people are sending him meteorites unsolicited that they've just like found in their yards. But they've heard of him and his work, and so they're sending him meteorites. And from there, it's not too far a stretch for him to be one of the researchers who studies lunar samples that are returned by the Apollo mission in 1969. Again, a disappointing lack of microbial alien hitchhikers on those, but he gets a pretty cool souvenir out of the deal, which is a moon rock that he puts on display in his Berkeley office. And so after 1970, Calvin kind of drops off the SETI astrobiology scene. He still lectures and attends conferences on life in the universe, but he's kind of cycled back around to feeling like he doesn't really have any research to contribute. And oftentimes he really doesn't feel like he's a SETI scientist himself. And history has kind of treated him the same way. You know, we don't think about people who have heard of Melvin Calvin, don't think about, you know, his origins of life experiment or his picking with meteorites or moon rocks. What people remember him for is his photosynthesis research. But I think that without actually realizing it, Calvin's photosynthesis research was kind of the best gift he could have given his SETI astrobiology pals, other than the pins. Because in 1992, when Frank Drake was reflecting on this meeting in his own SETI memoir, and thinking about how secretive and fringe this whole thing felt and how the scientists didn't think that perhaps the larger scientific community would understand their interest in aliens, he writes, "This may sound crazy, but sharing the moment when Melvin Calvin won the Nobel Prize with Calvin was almost kind of like sharing the prize itself. I felt that somehow our group and the topic we were discussing had suddenly been raised to a higher credibility by Calvin's new standing in the public eye, for the Nobel Prize is such a coveted honor that it rubs off on anything the recipient touches." And so in this sense, you know, Melvin Calvin might not have been able to contribute to the research that he wanted to SETI, but his photosynthesis research did at least give his fellow SETI pioneers some sense of scientific street cred. Thank you. Everyone's like, can I please go home now?
Was he aware of and did he ever respond to the work that found amino acids and other sort of more or less macromolecule traces in various outer space locations? Was he around when that stuff was coming out?
I don't believe so. I think that pretty much after the Apollo mission stuff, he was a little bit out of it. He might have been aware in the sense that he attended several sorts of like in the universe conferences afterwards throughout the 70s and 80s. But a lot of his work, especially in the decades following the Order of the Dolphin conference, was him trying to direct this lab of a couple of hundred people. And so a lot of his sort of really in-depth into the SETI community stuff was in his earlier years of his career. Yeah.
Hi, so you used an interesting term in your presentation, and I just wanted you to expand on it. You said lifelike intelligence.
Oh, sorry, I meant to say human-like intelligence.
Okay.
Yes.
All right, so, but going with that,
Yeah.
what I heard, okay, maybe I just heard it. Maybe I made it up. In your research or everything that you read, have you come across any kind of other conception of intelligence that doesn't involve life or the molecules of life that we know them? You know, I'm thinking about computers, but you can also be thinking about any kind of information processing. Is there a possibility, is there models of information processing that are totally, based on either other chemistries or just minerals that are out there in the galaxies?
Sure. Yeah, if you're interested in this, there's actually a really cool book called Civilizations Beyond Earth that has many chapters that kind of explore those more speculative sorts of questions about what constitutes intelligence, as far as, I think there's one in there about perhaps like silicon-based intelligence, and then something about individual beings networking to create some larger intelligence. I didn't really focus on that quite as much for the Melvin Calvin stuff that I was doing, because he was so pragmatic and didn't even want to think about, like when people would ask him what he thought aliens might be like, he was just like, I think they're probably carbon-based, or at least I hope so, because otherwise I don't know how to find them. But there are several people who have gotten into the more speculative aspects of SETI, especially philosophers like Nick Bostrom, who are more open to those sorts of other possibilities. So I think there are people like Melvin Calvin who are like, if we're going to do SETI, we have to do it in the most practical way, and we can only focus on the type of intelligence that we might recognize. And then there are other people who are more willing to keep an open mind about what aliens might look like and what other intelligence in the universe might look like. So I think it's just kind of a pick your own flavor of SETI scientist.
Yeah, well, but even the term SETI, there's no assumption there that it's related to life. It's just about intelligence.
Yeah, I would say it's kind of a similar situation here as to the definitions in Bennett's studies of what qualifies as successful aging. For every 28 people you survey, you'll probably get 300 answers. So yeah, I think in this case, when the Order of the Dolphin was meeting, at least, what they decided to qualify as intelligence was beings who could build and operate radio telescopes to send signals to outer space. Because that was the only way that they figured that they would be able to pick up alien signals. And so it wasn't perhaps so much a philosophical decision that they decided radio telescope building is the be-all, end-all definer of intelligence, but it was the only way that they really knew how to go forward with their conversation was if they made that their sort of baseline. So, yeah.
So why radio instead of light communications or X-ray or something like that? Why is radio the right way to look?
Sure. So of the entire electromagnetic spectrum, I think probably because other than sort of optical astronomy, radio astronomy was the next thing that was sort of conceived and built. So infrared and X-ray and those other types of telescopes came later.
It's the absorption of the atmosphere.
Yeah. So
the radio waves go through at certain rates better than anything else. So
Well, not
it's
just
totally
the
practical.
Not just the atmosphere, but the whole interstellar.
The whole
medium.
interstellar medium, yeah.
Okay.
The others are absorbed.
So you need to build a space telescope if you want to look at infrared or X-rays. So.
Is
Is there so the SETI scientists face some skepticism or concerned about facing skepticism. Is there any research going on today along the SETI type research going on that's federally funded? And if so, do those researchers face similar skepticism?
So I don't know about any federally funded SETI research today. I think that after the mid-90s, when NASA cut its sort of SETI program, the SETI Institute was established, it's all, at least to my knowledge, been privately funded since then. So these days we have like the Breakthrough experiment that is it Yuri Milner, this billionaire, has funded for the Green Bank telescope, as well as some other really big radio telescopes around the world, to dedicate some amount of time to radio SETI searches. But those are all sort of like really big philanthropists who are footing the bill for those. So.
We have time for one more question.
I was at the Green Bank National Radio Observatory. Have you ever been there?
Thanks, Dad. Everyone, this is my dad. In fact, I have spent so much time, probably more time than anyone's spent, other than the people who work at Green Bank, because it takes so long to get out there. But yeah, so the radio telescope that Frank Drake used for the first ever SETI search is still there, as well as an enormous, terrifyingly big radio telescope that I was able to go talk last summer. But yeah.
So what's your favorite science fiction movie that pertains to SETI?
Ooh. I mean, I guess I kind of have to say Contact, right? So since Carl Sagan is one of my bros in the SETI squad, and also because they actually filmed at these radio telescopes that are quite famous around the world. So.
Thank you, Maria. And again. Let's take one more cumulative hand to our graduates. I hope all of you